Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math questions out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 229. And today is our lesson number 107. Let's turn to page number 229. And the problem that we want to work on is 2.6.2. 2.6.2. Before we work on that problem, yesterday on day number 106, I gave you homework. The homework was, my question was, what does the square root of 9 mean? What does it mean when you say square root of 9? Can you articulate it? Can you describe it? Can you express it in simple words? What is it that you're asking here? Square root of 9. When you ask somebody, what's the square root of 9? When you ask somebody what simple question, what's the square root of 9? What is it that is being asked in fact there? What is being asked here is this. It says give me a number which when multiplied by itself gives us 9. That's what we're saying here. That's the question here. It says the square root of 9 means, when somebody says what's the square root of 9, what they're saying is, give me a number which when multiplied by itself gives us 9. And the answers are, there are two answers, not just an answer, answers. Even though here it says give me a number, in fact it should have said give me all the numbers. Give me all the numbers which when multiplied by themselves give us 9. Let's change it, let's fix it. Because there is more than one answer. There is more than one number which will do the job. Give me all the numbers which when multiplied by themselves give us 9. And can you think of more than one numbers? Well, one is very easy to remember. One number is very easy to figure out, which is a positive 3. A positive 3 times a positive 3 will give us 9, or positive 9 if you like. That's what this is, 9. Will give us 9, or positive 9 if you like. What's the other one? The other number is negative 3. A negative 3 times a negative 3 will also give us 9. So there are two answers here. There are two answers. Positive 3 and negative 3. Positive 3 times positive 3 gives us 9, and negative 3 times negative 3 equals 9. Therefore, the square root of 9 equals positive 3, and the square root of 9 also equals negative 3. Now instead of writing it separately like this two times, here's how mathematicians like to do it. They like to condense everything in one way, which is this. Square root of 9 equals positive 3 and a negative 3. That's how we write it. A positive 3 and a negative 3. This is read as positive 3 and negative 3. That's it. Square root of 9 is not 3. Well, square root of 9 is not just 3. It is also negative 3. If somebody asks you what's the square root of 9, the full and the complete answer would be either positive 3 or negative 3. Because negative 3 times negative 3 is 9, and positive 3 times positive 3 is 9. Because that's what the square root means. Square root means give me all the numbers which when multiplied by themselves give us 9. Now let's ask here this question. We're gonna make it a little kinky, okay? This is gonna get a little prickly, so stay with me. I need the room, so I need to erase all this thing. Let's erase all of this thing. here's the new questions. It says, give me all the numbers which, when multiplied by themselves, give us -9. In other words, now the question is, what is the square root of -9? What number multiplied by itself will equal -9? That's the question. What number multiplied by itself will equal -9? And the answer is, no such number exists. No such number exists. Why? Because if it's a number, it's got to be either positive or negative. Stay with me in this story. If it's a number, for example, 5 is a number, and -5 is a number. If it's a number, it's either positive or negative. If it's positive, positive times positive will give us positive. And if it's negative, if it happens to be negative, then negative times negative will give us positive. It is impossible for a number to be multiplied by itself and result in a negative quantity. I'm going to say it one more time. It is impossible for a number to multiply by itself and result in a negative quantity. It is not possible. Because that number that you're multiplying by itself is either positive or negative. If it's positive, then positive times positive is positive. It's going to result in a positive quantity. Or if the number that you're starting out with is negative, then that number multiplied by itself, which in essence what you're doing is negative times negative, will result in a positive. It is not possible for a number to multiply by itself and result in a negative quantity. It is impossible. It does not exist. This does not exist. No such number exists. No such number exists. Again, as I said before yesterday, what we're doing here is learning enough mathematics for us to do well on the GRE. We're not here to turn ourselves into nerds and geeks and freaks. In other words, mathematicians. We're not here to turn ourselves into mathematicians. Mathematicians talk about the real number and imaginary numbers. They will tell you that the square root of -9 does exist, but it's not a real number. It's an imaginary number. To which you will say to the mathematician, go F yourself. Because we're not interested in imaginary numbers. Last time I tried paying my mortgage with the imaginary dollars, they did not take it. They prefer real numbers. Do you understand? So we're going to deal with the real numbers only. Don't worry about imaginary numbers. As far as mathematicians are concerned, there exists an imaginary world in which they work, where they use imaginary numbers. We're not interested in it. GRE is not interested in it. You'll never deal with it. Okay? That's all. So as far as we are concerned, no real number exists. I should say no such number exists. For mathematicians, mathematicians will say no such real number exists. For us, no such number exists. That's it. So let's carry on then. Let's see what happens here. So it doesn't exist. No such real number exists. Let's see, where was I? Therefore, if somebody were to ask you, I need the room here. I'm going to erase all of this thing. We're done with it. Therefore, if somebody were to ask you what is the square root of x here, if the square root of x happens to be a function, let's call it a of x. And if you do not know what I'm talking about just now, a of x, which means, if you do not understand this part, it simply means that you did not watch yesterday's video. It is very important that you watch them in sequence. If you're going to jump around and if you don't understand things, that's your problem. Here, there is a relationship between some variable y and some variable x. The relationship is like this: y equals square root of x. And we're giving this name, we're calling this relationship, we're giving this relationship a name, we're calling the relationship A. In this relationship, in A of x, what are all possible values of x? In other words, In other words, what we're asking, again, this has to do with yesterday. In other words, we are asking what is the domain of this function? What is the domain of this function? Which is same as asking what are all possible values of x that we can have in this relationship? And the answer is, x can have any values it wants, as long as x is positive. As long as x is positive, because if x were negative, we will have trouble. X can be 5, x can be 15, x can be 37, x can be 0.345, but x cannot be negative 2. Because square root of negative number does not exist, as we just discussed. The square root of negative number does not exist. No real number exists. Square root of negative, no real number exists which, when multiplied by itself, will result in a negative quantity. It doesn't exist. So the question here is, what are all possible values of x? The answer is, in other words, what we are asking here is, what is the domain of this function? The answer is, x can have any values it wants as long as x is positive. That's all. That's all. Now, let's look at one more. Let's call it b of x, a different relationship. b of x, let's call it, which is x plus 2. Here, x can have, so here if somebody were to ask you for this function, we're done with the first function, let's erase it so we don't get confused. I'm calling this relationship b to keep it separate from the first relationship that we just talked about, which we refer to as a. Again, one more time, if you do not know what the hell I'm talking about, you must watch yesterday's video, okay? b of x equals y. In this relationship, the question again is, what are all possible values of y in this function, in this relationship? In other words, we are asking here, what is the domain of this function? Again, the answer is x can have any values it wants as long as this quantity that we see here under the square root sign, as long as x plus 2 is a positive quantity. And when is x plus 2 going to be a positive quantity? X plus 2 is going to be a positive quantity greater than 0 when x is greater than 2. That's all. Because if x were less than 2, for example 1.9, as long as x is positive, which implies, well, I've not done a better job here, have I? We have to solve this for x. Let's subtract 2 from both sides, and this 2 cancels out. As long as x is greater than negative 2, not 2, I'm sorry. As long as x is greater than negative 2. For example, if x were negative 1.9, if x is equal to negative 1.9, then x plus 2 would be negative 1.9 plus a 2, which is 0.1. And since it's a positive quantity, we can figure out the square root of it. But x cannot be negative 2.1. If x is negative 2.1, plus a 2 will result in a negative 0.1, and the square root of negative 0.1 does not exist. Does not exist. That's all. So in this case, we said that the domain of this function is all the values of x that are greater than negative 2. The domain of this function is, let me erase this part, I need to write it. domain of this function is all values of x. X can have any values, all values of x except all values of x as long as x is greater than -2. That's all. As long as x is greater than -2. Or greater than or equal to, as a matter of fact, because in that case, it will get a square root of, if x is equal to -2, we'll get a 0 in this, 0, and a square root of 0, of course, is 0. So I was wrong. As long as it's greater than or equal to -2. As long as it's greater than or equal to -2. Now let's do the problem that they give us. 2.6.2. They're calling the relationship g of x, and it looks something like this: x cubed plus, there you go, you see? Anything else? Minus 10. Minus the 10 does not play any role. Now, had it been simply like this, x cubed, then there will be no restriction on x at all. Here, there will be no restriction on x at all. X can have any value it wants, positive, negative, 0, anything at all, fraction, anything at all. So this is not the one, this is not the guy who's causing the problem. The guy who's causing the problem is this guy. This quantity under the square root sign, here, in this function, the quantity under the square root sign cannot be negative. In other words, x plus 2 has to be a positive quantity. That is, x plus 2 has to be more than 0, more than or equal to 0. If we subtract 2 from both sides, x, in other words, x has to be more than or equal to -2. Same as before. X has to be more than or equal to -2 in this function. What was the question asking? So I'm going to read again 2.6.2. I'm going to read it verbatim. Turn to the page 229. Read it with me. It says, let g be the function defined as, right here, that's your g. In this case, g of x is not a real number if x happens to be less than 2, or less than -2, which is what we're saying here. Hence, the domain of g consists of all real number such that x is greater than or equal to -2. That's all. That's the domain. Let's move on then. We're done with this one. Let's move on to the last one. Let's see what the last one is talking about. Here and there, if I make small errors, just ignore them. Just learn whatever it is that you can learn from it, and don't get hung over on a small, minute mistake when I end up saying something inadvertently. Just ignore it. You should be smart enough to realize what was said inadvertently and what was the real mistake. That's it. We're done with this one. Let's do the next one. People send me annoying emails about the tiny little mistake that I end up making in the videos, things that I end up writing inadvertently, things that I end up saying inadvertently. For example, I might write 4 and refer to it as a 5. No big deal. You know what it was for. Don't make a fuss about it. You don't need to send me an email about it. Let's do the next one, which is on page number, which is on the same page, 2.6.3. Here we have a function, they're calling it h. H of x equals absolute value of x. Here, values of the function are the absolute values of x. That is, this is your y, this is your y. That is, y equals absolute values of x. In other words, what we are saying here is, I'm going to erase all of this thing, we don't need it. When the y happens to be, we are told that it is the absolute value of some other quantity, what we are saying here is that the value of y, it does not matter whether x happens to be 7 units to the right of 0 or whether x happens to be 7 units to the left of 0. It doesn't matter whether x is positive 7 or negative 7. In both cases, our y, which is the value of the function, equals positive 7. In other words, we are interested in measuring distances. This is a distance and this is a distance. Here y, here, just sort of drawing a annoying line like that. Here y denotes, or signifies, if you like, denotes the distance from 0. And distance just means distance. Distance cannot be negative, and distances cannot be negative. Distances by definitions are positive, which is why we write this as an absolute value of x. When was the last time you got in your car and drove negative 20 miles? One doesn't usually drive negative 20 miles. Distances have to be positive. Whether you're going 20 miles this way or 20 miles that way, it's still 20 miles. You're not going to refer to one as a positive 20 mile and one as a negative 20 mile unless you happen to be some geek, some freak, some nerd, like a mathematician. Ordinary people do not talk about negative negative distances. So therefore, if you're conveying an idea that it is always a positive quantity, the way we do that in mathematics is by putting this symbol here, which is read as the absolute value. It's the absolute value. It is not whether it's to the left of the 0 or the right of the 0. It is, absolute value means it is how far is it from 0. That's all. The direction doesn't matter here. Let's see, what exactly are they asking here? Okay, I'm going to read now 2.6.3 so that in case if I miss something, let h be the function defined as the h of x, which is the absolute value. Absolute value of x, which is the distance from between x and 0. I'm reading it from the book, you understand? Which is what we just talked about. The domain of h is all real number of x. Which reflects. That's all he's talking about. He says the value x can have any values it wants, positive or negative. The y will always be positive. So here, where can I write it? I need the room. I have to erase this thing. I need the room. Here, x can have any value it wants, but y will always have to be positive. And how do we say it in the language of mathematics? In the language of mathematics, the mathematician would say, here, the domain is any real number, but the range is only positive value. positive numbers. The negative numbers do not apply here. Y cannot take a negative number. That's all it is. That's all. We're done. I'm done with these three problems. 2.6, 2.6.1, 2.6.2 and 2.6.3. These problems were done in the book. They involve the concept of function, but these people did such a cursory job on it that I thought I saw the necessity of actually going over in detail so that people understand what the concept of function actually means. I just use this word cursory. My problem is I cannot spell things. Learn this word cursory. What does it mean to do something in a cursory manner? When did we learn this word? Let's find out the day and learn this word cursory. See. Cursory. I know we learned it. I know for a fact. I'm talking about the vocabulary videos that I have put on the YouTube where we learn vocabulary words for the GRE to help you improve your score in the verbal part. And the word is cursory. Just give me 2 more seconds. I'll find the day so that you can watch the video. Oh, there you go. Day number 22. Just type in vocabulary day 22 with my name and will pop right up. Cursory. To do something in a cursory manner means to do something in a hasty manner. They did such a cursory job on these three problems here as if it's such a casual concept, function. No, function is not a casual, trivial concept. It's a very important concept in mathematics. It is a very crucial concept. You must understand what it means for one variable to be the function of the other variable, and why do we say f of x sometime and g of x some other time and h of x other time. These are very basic concepts that you have to understand, which is why we did it. The adverb for cursory would be cursorily. If something is done cursorily, what you're telling me is that it is done hastily. So if one is doing things in a cursory manner, one is doing it cursorily. That's all. We're done for today. I'll see you tomorrow, okay? Bye now.